All right, hi everyone. So my name is Aiden Flaherty, and today I'm going to be presenting my project on optimizing audit staffing decisions for my hypothetical company, Aiden's Audits. And the goal of this project is determine how to assign audit analysts to work streams in a way that both minimizes labor cost while also still ensuring that all the required work is completed. And I did this using prescriptive analytics. So to start us off with an executive summary, we can kind of see that cost-efficient staffing is achievable, but it's constrained by skills and capacity. And this project focuses on a common problem that I've seen in internal audit, which is having limited analyst hours, different skill constraints across work streams, and of course, staying within the weekly budget. To solve this, I built a mixed integer programming model using Excel Solver, and it optimized both the staffing assignments as well as the hours. And based on the model results, I recommend using this approach for weekly staffing decisions, increasing flexibility of associate working hours and workstream hours where possible, as well as cross-training analysts, especially IT, to reduce any sort of bottlenecks. And the key takeaway is that a cost-efficient staffing plan is achievable, but success heavily depends on flexibility and skill coverage. But now that you have kind of a broad overview, let's get a little bit deeper. To give you more of a business understanding, we see that audit staffing requires balancing cost, capacity, and skill constraints. This project is based on an internal audit firm with multiple weekly work streams that require both IT and financial analysts. And the core decision is who should work on what and for how many hours during the week, with the main objective of minimizing total labor costs as well as meeting those skill constraints. Those include analyst capacity, required skills, budget limits, as well as only being able to work on a maximum of two work streams per analyst. This really reflects real world staffing challenges where cost, availability, and expertise all need to be perfectly balanced for work to get done. But before we move any further, we need to have a better understanding of the data and how it was prepped for the model. We found that workstream requirements and skill constraints really limit flexibility. So the data set has four main components: 12 analysts, seven work streams, a binary skill qualification matrix to indicate whether an analyst is able to work on a specific work stream. Um, and each insight or each analyst has attributes like hourly rate, maximum hours they can work, as well as their expertise. And the work streams really define required skills and hours. One important insight is that IT work streams require more specialized analysts, which reduces their flexibility compared to the financial work streams. So in order to do this right, I had to make some assumptions as well. My weekly demand is fixed. The analyst pay rates are staying constant, so they're not eligible for any sort of overtime. And their skills are binary meaning they are qualified or they aren't, aka one or zero. And to prepare this data, I had to structure the assignments into 5-hour blocks so that the model could efficiently handle the problem size in Excel Solver. When I did it without this, it just wasn't able to run it due to there being so much data. But now for the modeling approach, the model allocates analysts to minimize costs under their constraints using the mixed integer programming model. And I use this because it involves both discrete decisions as well as constraints. And it determines how many 5-hour blocks each analyst should be assigned to each work stream. And this really allows us to systematically evaluate all possible combinations and find the most cost-efficient solution. But this slide really shows how the model's structured. The decision variable at the top represents the number of 5-hour blocks that an analyst is assigned to in each work stream. And you can see it over in the screenshot of Solver as well. I've matched up the icons to make it easy to see where they align at. But as I've said before, the objective is really to minimize that total labor cost while still meeting all the workstream requirements and demand. There's several constraints as well. We need to stay within each analyst available capacity, only assign analysts to work streams that they're qualified for, limit them to a maximum of two work stream per hour, and make sure they're staying those assignments in the whole 5-hour blocks. So this is the full Excel implementation of the model. I'm not going to go into too much detail. I just want you guys to have a visual of what it actually looks like. But you can see at the top, there's really a description. Then everything just kind of ensures that all required hours are met while still respecting those constraints like analyst availability and limits. So overall, this model structure allows Solver to determine the most cost-efficient staffing plan, which is really beneficial. This is more the fun part where we can see the results of the model. And we found that optimal staffing meets the demands while still minimizing costs, which was great. The model successfully staffed all the work streams while minimizing the cost to $10,920, which was under our budget of $11,000. And this chart allows you to see a lot of those different results easily. The first is that two analysts were not used at all. This was interesting, and it happened because the model prioritized lower cost analysts and only used those higher cost senior analysts when their skills were actually required. We also see that the IT only had four analysts compared to the financial team's six, but their cost was only $660 less, showing that the IT team is a lot more specialized, but that also makes them more expensive to use. So the key insight here is really that not all available analysts are needed to meet the demand. Cost and skill constraints are ultimately driving the staffing decisions. However, I do realize that having two unused analysts isn't realistic, which brings me to our scenario analysis. And I tested two main scenarios to evaluate how the model responds to change in these key inputs. First, I increased each analyst available hours by two, and this helped reduce the total cost from 10,920 to 10,730. And it also increased overall analyst utilization because instead of having two unused analysts, we only had one. So this suggests that the original model was somewhat capacity constrained, and even small increases in those availability can improve our cost efficiency. Second is I tested what happens if an analyst becomes unavailable. In some cases, the model is still able to find a feasible solution, but in other cases, it became infeasible. And this occurs because of skill constraints and the limit of two work streams per analyst. So for example, since we have more financial analysts than IT analysts, if a financial one's missing, it's not too big of a deal because someone else can pick up the slack. But with IT, if someone's missing, the model is not able to run, which is a key limitation. But I'll get to that here in a second. But really, so even if the total hours are available, the model may not be flexible enough to reassign work depending on which analyst was removed, as I was just saying. So the biggest bottleneck is the reliance on these IT skilled analysts, since there are fewer of them, as I mentioned. This creates a risk where if one of these analysts is unavailable, the model may fail, and there just may not be enough qualified replacements. Another key constraint is the limit of the two work streams per analyst. This does help workers from being overworked, which is good, but it also reduces our flexibility and can make the model infeasible in certain situations. The model does have a few limitations, as I mentioned. It only considers for a single week and doesn't account for real long-term planning or analyst rotation. It also doesn't include fairness or workload balance, which are important in a real-world setting. This is why we see some analysts being unused during the week. So while the model does produce an optimal solution mathematically, it may not always reflect the most practical or sustainable staffing plan. But based on these results, I have four recommendations. First is using the model as a decision support tool for weekly staffing rather than a strict decision maker. Second is increasing flexibility, either by allowing more analysts to work more hours or just adjusting the work stream limits. Next is just investing in cross-training analysts, especially between IT and financial areas, because if someone's missing, it allows someone that might not primarily be working on that to jump over and help out, which will help whenever the model fails due to someone being out of the office. And lastly, continuously monitoring these results and just updating the model as conditions change, of course. So in terms of deployment, the model can be run weekly using the updated inputs for demand, budget, and analyst availability. And the output can be used to generate different staffing assignments, which can then be reviewed and adjusted as needed. So over time, you can use this week over week, which is really helpful. But now for the true business impact. First, it reduces unnecessary labor costs by identifying the most efficient staffing plan while still meeting all the workstream requirements. So instead of overstaffing or relying on your intuition, your decisions are actually being backed by data. Next is that it improves your staffing decisions on these weekly basis. A manager can use the model to quickly determine your optimal assignments rather than spending time manually going in, seeing who should work on what. This creates a strict and balanced program. And it also really is helpful for identifying those hidden efficiencies. For example, in this case, we saw that two analysts were completely unused, which helps us see that there's some excess capacity, especially when it came to IT. And that's not something you'd typically be able to find just in your day-to-day life. And the last key impact, or leads us to one more before our last, is that there's greater visibility into risk. The model is able to highlight where the organization is overly dependent on small group and specialized analysts. And now, lastly, it does support proactive workforce planning, getting ahead of things, identifying these gaps, and allowing the organization to take action when they need to. So the key takeaway is really that the optimization model is not replacing your decision making, it's just improving it. And it does that by quantifying trade-offs between costs, skills, and capacity. So thanks a lot for listening, and I really hope you were able to learn something from this.